Okay, so we told in this question that the instantaneous rate of population growth is proportional to its population size. So we've got this. So whenever we know that, so we're told that dp/dt, which is the rate of population growth, is proportional to the actual population. So this is the formula. This derivative being proportional to the original value means that the formula for the population is an exponential formula. Okay, so we don't know what the P0 is. It's e to the kt. So that's a general version of it. Okay, now we do know what P0 is because we're told that it's 10,000. So we've got this population here that starts with, what are we talking about? Years. So time in years and population. It starts at 10,000 and it goes up. And we're told that at 8 years, it's 15,000. Okay, now you don't need to draw this graph, but I'm just doing it for illustration. Okay, so the first part says, find an expression for the population size at the time of t years. In other words, we need to fill in the unknowns in this formula. We know P0, but we don't know what K is. Okay, so we know that P equals 10,000 e to the kt. And the bit of information that we have been given is that when t equals 8, the population has grown to 15,000. So 15,000 equals 10,000 times e to the 8k. Okay, easy enough, plug into calculator and you get 0.0507. And the question says, what's the equation? So the equation is P equals 10,000 e to the 0.0507 t. Okay, so now that we know that, the next question is really easy. So find the time taken for the population to double in size. So we want to know when's it going to get to 20,000, and that's 10,000 times e to the 0.0507 t. Solve for t, and you're going to get t equals about 13.67 years. Okay, and then the next part says, find the instantaneous rate of population growth when t equals 8. So whenever we look at rate of growth, we go to the derivative. So we know that dp/dt equals kp, and actually we know what k is, so let's put that in there, 0.0507 times p. Okay, and what's the population when we're doing it? So at t equals 8, we know what the population is because at t equals 8, p is equal to 15,000. We were told that. So that's easy, just multiply them together and you get roughly 760 people. So people per year. So that's the rate of growth. Okay, and then the last part is very similar. So let me do this here. Find when the rate of growth is 1,000. So that's just putting the numbers in differently. So dp/dt we know is equal to 0.0507 times p. So we know that what we want that to be 1,000 equals this, 0.0507 p. And remember, p is 10,000 times e to the 0.0507 t. Okay, so this times that. Easy enough to solve. So the time is, about 13 years, so 13.4 years. Okay, and what that's showing is when does the population growth get to 1,000? The instantaneous rate of population growth. In other words, when does the gradient of the graph become 1,000? Okay, so these are all pretty straightforward. It's just understanding the question so that you can get the equation right and then interpreting the question to figure out what numbers you need to plug in and what number you need to calculate.